This is a production of Cornell University.
Here now. So hello again, welcome to the Cornell Hemp webinar series. My name is Bahia Zal. If you're a regular attendee, you remember that I'm a second year PhD student in the plant breeding and genetics program at Cornell studying hemp with Dr. Larry Smart. Just so you know, these webinars are recorded, so you're able to share them with others or rewatch them. They're hosted on our Cornell School of Integrative Plant Sciences YouTube channel. You can also find more hemp resources on our Cornell Hemp website. I'll include links to those in the chat so everyone can take a look at them afterwards. So thanks everyone for joining again. And I would like to welcome our speaker, Wayne Swink. So Wayne Swink is currently a physical science technician at the USDA's New Orleans Cotton Quality and Innovation Research Unit, where he's been a key contributor on their hemp fiber processing and analysis project. Before joining the USDA, Wayne had a distinguished 20-year-long career in the military, and his journey has led him on an uncommon intersection of aerospace engineering, environmental sustainability, and has kind of culminated in a unique blend of skills and experiences. So Wayne is currently also pursuing a PhD in plant breeding at Texas A&M. But he's also spent 2 years doing human health related clinical trial research before joining the USDA. So Wayne collaborates with researchers from the Specialty Alternative Crops Grant, so including the Plant Genetic Resources Unit and other university researchers. He also engages with hemp researchers from the USDA's GIN lab in Stoneville, Mississippi. So with that introduction, thank you, Wayne, for joining us today. I'm really excited to hear what you have to say. I'll let you take it away.
Okay, thank you so much, Bahia. Howdy, everyone. Glad to be here. I'm very glad you're here to join this adventure into hemp fiber quality analysis. This should be a good presentation. Again, if you guys have any questions, which you might, I'm more than happy to answer them at the end. So here we go. So fiber quality analysis, it has a very distinct role in the market. So especially when we talk about natural fibers, manufacturers, buyers, stakeholders, they need to be able to identify certain fiber properties for specific end uses, right? And the best way we've done that is cotton. The USDA has established standards and a classification system, which uses grading quality. And because of this grading quality, buyers get a better understanding of the quality of the product they're buying. And then, of course, the seller, the farmer, the producer, also receives a fair market price in exchange. So for us as hemp breeders, especially when it comes to hemp fiber, there are going to be certain traits that we are going to select for and against. What's good about setting up like a classification system is that it becomes a benchmark for your selections, right? It's a reference for you to use to make your improvements in your programs. What's really big and interesting about hemp fiber is that as you guys design your projects, it's not necessarily just controlling the environment as we do with a lot of our breeding projects. Hemp fiber requires a lot of post-harvest processing. There are many steps in it. And so when you design your breeding programs, understand you're controlling the environment, define the genetics, but you also have to control the management, because if you start developing traits that look really nice, but can't survive the processing process, it's not going to be a whole lot of value to industry. So ultimately, what we're looking to do with fiber analysis is we're trying to grow the infrastructure of the hemp industry, right? We're just not quite there yet. And so if we can lay down some groundwork in this field, we can probably garner a lot of support from to grow hemp fiber and hopefully increase the yield of high quality hemp fiber crops being grown in the U.S. and again provide transparency to the actual value of hemp fiber. All right, so I just want to go through this real quick. So why is hemp fiber or fiber quality analysis, why is it even important? If you look at what the cotton industry has done, they kind of set a precedence for what the hemp industry can expect as we go along and try to set some standards here. And so why they were created, a little history lesson. 1907, U.S. cotton stakeholders got together. During that time, the markets were just insanely volatile, right? Market prices are always changing. You got farmers fighting, cotton brokers over the price of cotton, and then farmers, they're kind of being swindled a lot during this time, and because they don't really understand the value of their crop. And so the stakeholders get together, they lobby the federal government, and then 7 years later, legislation comes out, and so we started heading down the road where they're trying to standardize fiber analysis, right, or fiber quality. And so the USDA in 1923, the U.S. Cotton Standards Act, it directs the USDA to come up with a cotton classification system and then oversee it. And what's really important about the system is that we don't assign value to cotton quality. We assess it, right? And that's really big. We don't set the market prices. The market does that. We don't set the value. We just say, here are the qualities. Do with it what you think is important. So how does cotton classification gets done? It's the methods provided. So what it really is, it's the methods that we use is to provide the cotton industry with information on cotton quality for marketing and processing. It's a grading system, and the grading system's done on instrument standards through very defined, standardized methods, and on precision automated equipment, because fiber analysis, it can go really slow. It can go really slow. So if you can automate and make that process precise, there's value to have that kind of instrumentation around. So some of the parameters that are important with cotton classification, you'll see fiber length, uniformity, fiber strength, micronair, which is a combination between maturity and fineness, color, and then trash, how dirty your actual fibers are. So here we have a cotton quality grading. These are the actual standards or the grading system that the USDA uses. If you look up in this corner right up here, this is called the upper left-hand corner. So this is called the uniformity index, and that's the percent difference of long fibers to short fibers. And it's pretty much telling you like how many percentage-wise, how much short fiber you have in that sample. Fiber strength. Now, fiber strength is for hemp, it's really important, right? Because if you think about it, hemp doesn't have a really pleasant tactile property. And so for apparels and things like that, it's not very fun, right? It's an itchy day. But when we have used hemp fiber in technical textiles and processes, we've used them because it's strong. It's crazy strong, right? And so again, when we're breeding, I think this is going to be a really good selling point quality for adding hemp fiber into certain products, right? And then we have micronair, which again, this is kind of like fineness, maturity. Micronair is essentially like the diameter of the fiber. The thinner it is, right? The more you can put into, like, say, a cross section of yarn, or like a mat, like a weaving mat, if you're doing composites, which again kind of reinforces it and makes either the yarn stronger or the mat stronger. So color matters in cotton, and it's probably going to matter in hemp as well. You know, and the reason why it matters is because, you know, it matters with dyeing in cotton. So the whiter and brighter a cotton is, the less time it takes to dye it, and the longer that dye actually holds. So with this system in cotton, the USDA uses a two-part color system. And again, it's real simple. It's reflectance and yellowness. And then just a quick slide to kind of show you that how and why, like a real world example of how fiber analysis can actually bring a lot of value to the actual raw material. So this is what we call a CCC loan differential chart. And just real quick, essentially what it is, it's a loan offered to farmers to not sell their cotton when they harvest, because if everybody sold their cotton when they harvested, obviously the cotton supply in the market would flood, the farmer would lose money, and then obviously, you know, the demand wouldn't be really high, and so they would lose money. So this just lets them, you know, kind of hold on to the cotton, store it for a while until the market prices kind of meet what they expect, and then they can sell the market on the they can sell their cotton on the open market. So as you can see, just real quick example, say you got bales of cotton and they're average quality, right? And so at average quality under this loan, you know, the USDA would pay you 52 cents per pound for that cotton. And if you got a 500-pound bale of cotton, you know, your loan total per bale would be about $260. But if you grade out at the highest quality, it's 95 cents per pound, right? So your loan total for, you know, really high quality cotton is almost double. So really there is you know, there is a lot of opportunity to produce valuable traits and qualities, and then earn extra money off of that. So switching back to hemp again, sorry about that. So, you know, as we understand fiber and how they're used, we kind of have to look at the history a little bit. And just to keep things simple, I kind of broke it down into two eras, right? Pre-industrial and then post-industrial. So we've always had a relationship with hemp, right? You know, we've seen the history, we've seen the origin, right? It's probably started somewhere in China and then moved west to the New World. But hemp paper was pretty common back in those times. And as you can see, you know, a lot of times, you know, old rags and worn out clothes were kind of used as mediums for writing. And most of those items were made out of hemp. Come across some literature that says the first Bible was printed on hemp paper. I think a lot of us know, like, the drafts of the U.S. Declaration of Independence and Constitution were written on hemp paper. And then, you know, when we look at textiles, hemp always had a place in textiles. So rags, sacks, tablecloths. They made really good painting canvases. And of course, yarns, threads, twine, rope, and cordage. So around the 17th and 18th century, you know, the age of discovery in Europe happens. And this is where, you know, we got explorers doing transatlantic voyages, you know, discovering new things, new places. So these vessels were powered by you know, solar power, wind power, and to you know, survive those journeys, you know, they had hemp sails, real heavy, strong, you know, hemp sails to get them there. So this is where we can say what we can call, you know, industrial period of hemp. This is when it happened. This is when it was a really chief commodity. So again, during that time, hemp fiber gets the production increases throughout Europe for the sales, and then all the rigging that goes with sailing. So rigging ropes, cables, ladders, and stays. Again, some literature has shown that what really kind of kicked all of this off really was about mid 17th century. The French, they built cordage mills in their ports and kind of streamlined the shipbuilding process. And so they're building ships faster, and as they're building ships faster, they need more hemp, and so the hemp crop production is increasing, and the French's military, like naval might, is increasing, and it kind of almost starts an arms race, right? So the other countries see how their fleet is growing, and so they start doing the same thing, and if they couldn't, they started importing hemp, especially from Eastern European countries. And so again, this is where the hemp industry is kind of born. But it doesn't last. That's the problem, right? Because about the 1850s, transportation and war technology kind of had a drastic change. This is where the steam engine was created. And then again, in America, we found oil, right? We have US Steel. And so the concept of wooden boats and sailboats or ships, that goes by the wayside, and the production of these steamboats and these steamships come along. And if you just look at this chart real quick, you can see Italy, France, and Germany. This technology, the steamboats, happen about 1950, and then we see this sharp decline. This is between 1910 and 1920. That's World War One. You see a small peak, probably war effort stuff, if we're looking at the Italy line here. And then it drops around 1920, peaks, and then it just, goes down. So we can say that between about 1970 to until the 2018 Farm Bill, most of the hemp production in the world was done on small scales in either China or Eastern Europe. So when we talk about hemp fiber, we got to ask ourselves, what is it, right? So bast fibers, these are the fibers that you find in the phloem on the plant stock, and the physical composition of these fibers compared to something like cotton, which is a seed hair or a seed fiber, or wool, which is a protein fiber. It's very different, and the other thing we have to understand is that they're kind of, bast fibers are really bundled. They're just wrapped around each other. They're kind of just really a hot mess. When we talk about cotton or like something like wool, these are individualized fibers. They're already separated for us. They're already just, ready to go. So, so we can use hemp for a lot of things. It has been used for a lot of things. But there are new markets out there that I really think are promising when it comes to applying hemp, especially as technical fibers, for a lot of things. And in order for us to understand how they would apply to these new markets, we really have to get a really solid foundation, a solid rudimentary understanding of their actual properties, right? And then once we do, we can start exploring some of those unknown needs out there that we can apply hemp fiber to. And so, because it's so new and it really hasn't been studied, honestly, there really hasn't been a need to do too much when it comes to classification of hemp fiber. There's going to be a lot of challenges until we can actually, collect enough data till we can actually coalesce everything and understand what properties are going to be important. once we do. So, you know, we also have to look like I said, when we look at when we start designing our projects, and we're doing G by E, we really have to understand that in order to extract the fibers that we're looking for, if you're doing a specific fiber trait, it has to be processed. It has to go through a management process after post-harvest, and it could be very rigorous. So when we design those projects, we have to really consider the reting, the decortication, and then other factors that we just haven't come across just yet. So, and then of course, like it matters what the end use is. If you think about color, color could be, it's probably going to be important with apparels, right? If you're going to try to do a 70% cotton, 30% hemp t-shirt blend, right? But for the construction industry, does color really matter if you're going to, make a hemp concrete or use it as insulation? And so we got to figure out what's going to be important where. Right. So hemp fibers, where are they? If you look at this, right? If you look at the top right photo, and you kind of see that you got that white vascular looking tissue, those are where that's a phloem, and that's where you're going to find your primary fibers. And primary fibers, long high cellulose. These things can run the length of the stalk, or they can actually stop at the nodes and wrap around the nodes, kind of reinforce the branches. You can also find secondary fibers in the phloem, and these are small, much smaller fibers. They're made of the same stuff as primary fibers. They're just much shorter. And then if you look at the photo or the drawing to the right of that photo, you can see the xylem, that arrow pointing to the woody core. That's the stuff that we call the hurd, and that can be turned into products. It's got added value as well. So just another picture of kind of the inside of a stalk. I like this one very much, simply because if you compare this photograph to the photograph on the last slide, what's really interesting about this one is you can read, they kind of break down the parts. They have a very distinct primary bast fiber layer and then a secondary bast fiber layer. And then they call the layer in between the hurd glue. If you saw that last picture, it really, you couldn't really tell a distinct difference between a primary bast fiber layer and like a secondary, and this might be something, again, if we're trying to have breeding programs where we're chasing certain traits, this one might be really interesting. Does across all lines and all genotypes, do we have a distinct bast fiber layer and a distinct secondary fiber layer, right? And if we do, is that something we can select for or select against? It's a good phenotype. Okay, and then the anatomy of a hemp bast fiber. It's got 3 layers. It's got a primary wall, supposed to be around somewhere about 50% lignin, and then a 50% composition of like pectins and hemicellulose. The secondary walls is about 3 layers, and that's mostly cellulose. And then you got the middle lamella, which is 7% lignin, and then 30% hemicellulose. And then I like the slide as well. I like all my slides, by the way, or all my pictures, y'all. So on the right here, what you see is this is a cross section of a bast fiber bundles. And what's good about this is that you can see kind of how these fibers are just so bundled together. They're really right on top of each other, right next to each other. And again, when we talk about doing some kind of analysis, it almost seems impossible to try to tease out individual fibers. But again, it might be a thing where we just don't have to do that right now. So, and then if you look at the picture to the left, it's a longitudinal view of a single hemp fiber. I like this one as well because if you look at those diagonal lines perpendicular to the fiber, what I think those are the angles of the microfibrils, right? I've read literature that this could be a good phenotype, right, for fiber strength. I can't tell you if you have more strength, or you have less, you have more strength. But again, though, these are some ideas and some projects that I think for plant breeders would really make some serious headway. And then this slide, these are the types of products that are out there or you could make with hemp fiber. You look at textiles, wovens, knitting, apparel. I saw this, I was like, underwear, and first thing in my mind was like 100% underwear, and I was like, no. Denim, socks, and then I saw the socks, and I was like, yeah, that'd be the worst day ever. 100% hemp socks, 100% hemp underwear, but bags, shoes. And then if you look at the technical textiles, we got ropes, twine, nets, canvas bags, tarps, carpet, geotextiles, and then biocomposites. Means of transportation, probably not, but if we can create carbon fiber like reinforcing panels with hemp, we can do a lot of paneling on things that move. And of course, furnishes, construction things, garden stuff, and then packages. So this slide, just real quick, this is a company called Bast Fiber Tech. They are based out of Canada, I believe, and they provide raw hemp fiber to these three companies, the one out in Denmark, one in US, and one in Poland. And these companies are actually using hemp fiber for feminine hygiene products. Okay, so, we're now getting into like the analysis and what we think is gonna matter right out the gate when it comes to studying hemp fiber, right? So, like I said, we don't quite know what parameter is going to be important, what parameter is going to have value for industry. But again, if you look at the cotton, kind of set the precedence, right? And you kind of look at the properties of hemp fiber and just for us as a unit in general, what we think we can make headway on, and what should be probably the base of understanding quality analysis would be fiber length, tensile strength, the fineness, the color, and then of course purity, how clean those fibers are before it gets processed for its end use. So there's a lot of ways to go out and analyze fiber. What we're recommending here is this is more geared towards like an automated, streamlined process that would really, like I said, benefit not just academics, but the actual hemp industry. What can we do that's reliable, repeatable, and somewhat efficient, so that way we can get this data out as fast as possible. Well, not fast as possible, but relatively within a good time frame. I put up here manual. Obviously, no, that's I'm just saying manual. You can do it by hand, right? Nobody wants to do it. It's slow. It's highly variable from day to day, person to person, from lunch to breakfast. You don't want to do it, and because it's highly variable, it's hard to repeat. But if all else fails and we have to brute force, these measurements to find these qualities, there's always that. What we do know is there's photoelectric scanning out there. There are instruments designed with this kind of technology that exist already for fibers. Cotton, obviously. We have a couple systems for cotton that work really well, and in fact are used pretty much universally. And then digital imaging and optical. So we think this is probably going to be a good one as well. Again, if we talk about efficiency and automation, I think digital imaging and optical use is pretty good. And then mechanical, right? So like I said, I really think strength is going to matter. It's going to be a big deal. It's going to be a good selling point for hemp. And so there's all sorts of tensile testers out there, strength testers, that we can start using and applying. And like I said, and once we have that data, as breeders, you can start trying to select for that quality. And then of course, color. So we think color is going to matter. There's a lot of factors that play into certain colors, but it's just one of those things where if we can collect enough data as a field, we can come together and figure out how color plays into hemp fiber quality. So let's talk about some pieces of equipment. Like I said, photoelectric. In the cotton world, we got the HVI, which is a high volume instrument. And we have the APHIS, which is like the Advanced Fiber Information System. Again, these are both photoelectric. The HVI is great because it's almost like the one-stop shop for fiber quality analysis. So much so that like it's what the USDA uses to classify their or degrade the hemp or grade the cotton, and it's used all over the world. So I don't know if you guys have any cotton breeders in at Cornell, but if you do, they have one of these. So it's got built-in measurement software, so your results are almost instantaneous once you do that measurement. And then the APHIS, it kind of does it's similar technology. It doesn't measure as much as the HVI, but it can actually measure single fiber length. It does its measurements by single fibers, and it's pretty interesting. It's pretty cool. Of course, built-in software. But we think the photoelectric, that technology itself, it's probably going to be a good benefit to measuring certain hemp fiber qualities. So from there, we move on to digital imaging and optical. This one machine, it's called the OFTA, and that stands for Optical Fiber Diameter Analyzer. Nailed it. And it's used to measure wool. So it was engineered in Australia, which is, they grow a little, or they have a lot of wool out there. And it's essentially like an automated microscope. It can measure individual fibers, it can measure snippets, it can measure, beards or tufts. And so it's a good instrument, and it claims it can measure wool, cashmere, mohawk, which is goat hair. I didn't know that, silk, and synthetic fibers. And again, not as much as the HVI as far as parameters, but it can measure fiber length, fineness, diameter, and then some other fiber length measurements here. And of course, convenient built-in software. So, it was real quick going through the slides of kind of, those kind of analysis machines. Nothing exists specifically for hemp. So I talked about two of them, they're purely for cotton. I talked about one, it was designed for wool. Fortunately, you can do other things. And so researchers, breeders, like how do we, how can we kind of duplicate what the technology is out there for existing natural fibers without having to build like an entire system ourselves. So here at this unit, we came up with the idea of using digital imaging and optical. Like I said, the OFTA 4000 is pretty much an automated microscope. You know, we're kind of doing the same thing. So we have this VE 153G. All that is it's a digital microscope, right? It's supposed to be an industrial stereoscope, and it claims that it can measure biological samples. It's got built-in software, but if it can't measure these biological samples like hemp fiber, you know, we're prepared to explore some software programming, and some editing, and you know, the idea is that you know, if we have to go that route, we can then start, you know, maybe possibly building an algorithm that kind of points out the qualities that we're looking for and automate that as well. So from there, we're going to move into the mechanical testing, the tensile testing. So like I said, you know, single fiber testing is really good for cotton. It's really accurate, you know, really precise, and you get great data off of that, but it's very slow, number one. And those are individual fibers. So you know, they're not bundled like hemp fiber is. So you know, what we recommend if you're going to do any strength testing is to start with fiber bundles testing, right? It's, you know, again, it's not the pristine way of measuring fiber strength, but it is a good way, number one. And number two, it's less it's less, I don't want to say prep work, but it's just you know, getting those single fibers out of hemp is kind of hard. So anyway, so mechanical testing, what we're testing for is tensile strength. You know, strong fibers can withstand the processing better, and it makes for a better product, right? And so there's a lot of tensile strength testers out there. I'm just going to hit on a few that we think are going to work. And so this one right here, this is a picture of a Presley fiber bundle tester. This is an old school tester, tried and true. And you know, if you guys probably have one lying around somewhere at Cornell, excuse me. And so, and it's been really interesting too, because we've, you know, when we started talking about like analyzing fiber qualities, we really went back and looked at some of the antiquated pieces of equipment and wondered if maybe we should start there. Because again, all the instrumentation for natural fibers have advanced so much and so specifically for certain areas that you know, we thought, well, maybe we have to start all the way back there to get a chance to use instrumentation that can measure hemp fiber. And again, you know, this is another one. This is an old school one. This is a stylometer. It's still around because it works really well. This is a fiber strength and elongation bundle tester. And it can measure, you know, several types of natural fibers and synthetic fibers as well. But the drawback to this one is that it requires an extensive amount of sample preparation by hand. You know, you got to build these tufts into bundles, and you got to, you know, clamp them and cut them, and it's a lot of work. But again, it's a tried and true method. And when we talk about the bundle strength testing, slippage is a big concern of ours. And the way that works is that, you know, when you bundle fibers, if they're not all the same diameter, what can happen is when you're putting tensile forces on those fibers, there we go, on those fibers, and they actually start breaking. Some might not actually break until much later. They don't all break at once, like you wanted to you expect it to. They might slip a little bit and then break, or they might not even break at all and just absolutely slip through. So you know, that can affect data. So the one we have here and that we like, this is I'm not plugging products here, but this is the Instron Universal Tester. This is an electromechanical universal tester, and the reason why I like this is because it can do a lot more than just tensile strength. As you can see, it does compression, bend, peel, tear, friction, shear. So again, say you're going to work with composites, say you're going to work with weaving material. This thing can measure those hemp fiber properties in those products. So it's pretty nice. The one drawback is that you got to get accessories. You got to put in money to get the types of clamps or platens or rams that you need for this thing. And again, the testing limitation, it's the fiber slippage. It's something we're gonna have to account for. Okay, and then color. So color is going to be really important, again, for dyes and all that kind of stuff. But for hemp, it's really cool because color might be able to tell us a lot of things, right? The degree of reting, right? Fiber maturity, fiber quality. These could all be things that are associated with color. And so color's quick enough for us, it's not that big of a deal. So I do recommend, with your samples to start taking color. Here, we're taking color. We got over 10,000 individual raw stocks through the SAC grant guys. I'm convinced they just don't like me. They keep sending them, but we got the for us, we need it quick. So we have this spectrophotometer. It's a handheld device. It's easy, convenient, comes with calibration tiles. It's got color reference tiles, and you can use several color space methods with the software. So here we like the old C-Lab. We think that's a good one. Right. And so beyond instrumentation, I really want to talk about this because this is really important, is fiber processing. Like I said, you got to do G by E by M, your traits that you're chasing down, they have to survive the mechanical processing. Because nothing would be worse than to have a really good trait and then send it through, a decorticator and a scutcher and have that trace just be lost, right? Be heartbreaking. So when we look at hemp fiber processing and we think about it on an industrial scale, there's always, not always, but there can be a pre-treatment, right? But there's always going to be a mechanical processing, especially on a large scale. We can't escape that. That's just going to happen. So, you can do a whole bunch of pre-treatments, reting, different types of reting, chemical, reting, things like that. But just real quick, if nobody some people don't know that reting is just like it's a biotech, right? You use microorganisms to kind of break down all the glue, the hemicellulose, pectins, and lignin within bast fibers, so that way you can actually process them better, have them separate easier. And then, you got, it's highly dependent on the environment. The type that I like, that I like to see is the old school type where it's just the field retting, you just cut it and leave it and let nature do its thing. I'm sure some of you guys have come across the micro basts, the wet retting, and that is just a giant environmental hazard. I like to avoid that. So, but again, to the degree that you ret, it affects the ease of decortication. It affects the fiber quality in some way. Might not always be bad, might be good. But in your projects, these are things that you want to understand and point out and see how it happens. And then of course understand you're going to lose biomass, right? You got these microbes in there eating all the stuff that they want to eat, and they leave the rest of the stuff that they don't want behind. And so essentially you lose some biomass there. So from the pre-treatment, then we go into the mechanical processing steps, right? And again, many ways to do it, right? I just broke it down into 3 just main steps that you normally see, right? And it starts with breaking or decorticating, and this involves breaking the stem to extract fiber and separate the hurd. Then you have scutching, which softens the fiber a bit, separates secondary fibers or elementary fibers, and then further removes fiber from the herd because it never, once it goes through breaking, it's not completely clean. And then it goes into hackling, and hackling is this combing process, right? Where it kind of conditions the fibers, softens it, and opens them up. And this picture, courtesy of Anthony at USDA-ARS, or excuse me, ARS. Thank you. Absolutely love this picture. This is beautiful, right? So what we have up top, as you can see, these are stems that are unretted. And, it's a time lapse. As you go further and further down to the end, you can see how those microbes have done their job. And if you look at, was it B8 and A8, you can kind of see where the fibers are starting to separate from the herd, and that's a big advantage to reting. Okay, real quick example of fiber processing for textiles, right? You start out as, in this case, they call it hemp straw, right? Goes into reting, and from reting goes into scutching. And again, scutching involves probably decorticating in this case. And then they separate the biomass. You got the shives, which are the herd, the waste, those are thrown to the side. But then you got the long fibers after scutching and short fibers. They start to separate. The long fibers go into hackling. And then they get separated from long fibers and short fibers. But these three biomaterials, starting from the right to the left, those are our products that are being spun into yarn. So back to the 3 steps. What do we got? We got breaking, decorticating. Many ways to do it. I know I&D uses a modified hammer mill. This is just there are different techniques out there, right? This one I like. This one I think is pretty interesting, and I saw this a lot in old publications and old pictures and stuff. But this one I like. So it starts with a feed tray, which is on the left-hand side, and what's laying on the feed tray and going through the rollers obviously is a hemp stem. So you see those small fluted rollers, those would be like feed rollers or crush rollers. They kind of control the speed at which the hemp stalk is fed. And it also does some pre-crushing of the stalk to start separating herd and fiber. And then once it goes through those rollers, it enters the big diameter paddle rollers, if you want to call those. And that would be the breaker, and that really starts breaking off pieces of herd from the stem, and it starts to begin that extraction process. So after that, the next step would be scutching, right? And again, this is where the remaining woody core that's still sticking to the fiber would be conditioned off. And again, more softening, more opening of the fibers, more separation between primary and secondary fibers. And then hackling. I didn't have a good picture. I couldn't find a good picture of, like an automated hackler. But they have automated that before. So hackling combing, essentially is fibers being pulled through pens. And again, opening fiber, removing the stuff you don't want. Oh, so I was supposed to pause there for a second and give you guys like this little like speech thing I had prepared, but this is our lab scale decorticator here at ARS. This is something we designed with plant breeders in mind, right? Hemp breeders in mind. This is a single stalk decorticator, and it's got variable speed. It is we're proud of it, right? So it's a single stalk decorticator. It's got 3 modules. It's one entire system. The idea behind this, the reason why we engineered this here is because it suits our needs as a unit when it comes to trying to phenotype fiber quality. And so with this system, there's 2 things that we're looking at. We're looking at ease of decortication, through power, right? And we're also looking at fiber herd ratio. Okay, for you in this real quick case study. So I talked about the OFTA 4000 a little ways back. So Dr. Christel Holm is partnered with Texas Tech University, and they're testing the OFTA to see if we could use it as an instrument to test hemp fiber. And so this study isn't done. I actually sent them more fiber this week for them to test. But they're getting results, and they're continuing on with the study, and I think there might be some good things coming from it. So at first they wanted to test the accuracy of the OFTA. And so they fed it this treatment right here, right? So they fed it rayon, polyester, and then a different type of polyester. And they wanted to see, again, how repeatable, how accurate, how consistent this machine was. They gave it 2 treatments, a tough treatment and a slide treatment, and then had 5 reps over 3 days. And here's a line graph of the results, right? Top left is day 1, right? That is day 1 tough mode treatment, day 2 tough mode treatment, day 3 tough mode treatment, and then day 3 slide mode treatment. And as you can see, the consistency of the data that the OFTA is reporting, it looks pretty good, right? I wouldn't complain about it. So, so they kind of wanted to test that the OFTA is doing what it says it can do. And then from there, they went ahead and started testing cottonized hemp. And again, the idea was cottonized hemp is so refined, it's so processed, it's so similar to cotton that if the OFTA couldn't do certain quality parameters, such as like length and diameter, that this would kind of kill the study. And so they used a tough mode. They probably used the slide mode. I don't think they have that info just yet. But for this, they used the tough mode. In this case, 6 reps per sample. Oh, I forgot. I don't I don't have the other slide. I had to take some data out because they're going to post it. My bad. I'm sorry. They're actually going to publish the data. So anyway, moving on. So if you looked at the last slide, if that thing didn't quite work on cottonized hemp, they probably wouldn't have moved on to non-degummed hemp. So this is stuff that's still that's unreaded, right? But they did. They moved on to it, and they gave it their sample population broke down into long, middle, and short hemp fibers, and then this time 2 treatments and 6 reps. So guys, in conclusion, right? Hemp fiber quality analysis is really key to identifying desirable fiber traits. We don't know exactly what properties are going to be important for what end uses. And what makes it even harder is that we just don't have any hemp specific tools, right? So we're still in the process. We're still in the discovery phase of developing and modifying and creating instruments or methods. We're still in that phase where we're still crawling, right? But once we get past that crawling phase, we can end up to a point where we can start developing, a fiber classification system. And, if we can do that for industry, it will stabilize market prices, right? Buyers are going to get what they want, right? They're getting the products that they expect to get. And of course, sellers are getting their just dues for producing high quality hemp fiber. And then again, for you guys and for me as hemp breeders, once we have this information, once we have a classification, once we kind of know what's important, we can use those as benchmarks for improvement. And I can't express this enough, guys. It's not just G by E. Got to understand the management. You got to understand this is going to go through your traits are going to go through some really heavy duty processing to extract that fiber. So really what our goal is what I like to think our goal is, as a unit, as a problem solving service, but, as a researcher, right? Um, we're here to support the industry, right? We're here to support the economy, support society, right? So once we kind of lock in on what's important when it comes to fiber quality analysis, let's what I'm hoping is we can grow that infrastructure here in the US, right? Get more processes out there, grow more support for the hemp fiber industry, right? And in turn, start increasing production and increasing not just production, but increasing high quality hemp fiber crops. Um, and then of course, we got to provide that transparency to place value on those crops. And then, of course, and again, if you're anything like me, I got a sustainability background, so this is really near and dear to my heart. But if we can inject, a sustainable material into our economy to replace some, uh, open loops, open loop products, that would mean, that would mean a lot to me. So, but anyway, I thank you guys for being here. I really enjoyed this. And if you have any questions, I'm standing by.
So I think there's already some questions in the Q&A box. You can open up and look through them. And everyone else, if you have some questions, please add them.
So Dr. Sokoff, sorry if I mispronounced that. Can you hear me?
Yes, can you repeat the question?
So his question is, do you have any recommendations for lab scale equipment for opening, picking, carding hemp fiber after decortication or degumming? I think honestly, I think you're probably a little further in this than I am. We do have a lot of carders. Um, uh, but the problem is they're all for cotton, right? And so right now we got a couple of carders that we have that think might work. We kind of use them to test sticky cotton, so they're a little bit more rugged and open, and I'll give you my email, and I'll just we can email about this because we're also exploring the idea of maybe engineering something just specifically for hemp on a small scale. And then Jamie. Yeah. So Jamie asked, is there any value in degumming hemp threads for its practical application? 100%. Yep, 100%. Again, it depends on, when we talk about it, it depends on its end use, right? If you're going to make, some, I don't know, some nice hemp shoes or something, I'm just pulling this out there, right? You'd want your fibers clean, right? You'd want your fibers clean because, some tight stitching there, you want it to look nice. And of course you need those properties, the qualities of many other shoes. So you want them to be strong, you want them to hold up. And degumming kind of, like I said, it kind of hinders the processing of all that stuff. So the cleaner you can get your fibers, the better. So I hope that answers your question. So, and then to Tyler Gordon. Hey, Tyler. Tyler wrote, do you have any other labs? Do you know if any other labs are working on hemp fiber standards? And are you working in collaboration with those groups? I do know of them. I know Dr. Christo Home is in contact with those labs. Me personally, I'm not that high in the totem pole to interact with those guys. So, and then, so Dr. Smart, so he asked, what is fiber maturity in hemp fiber and why is it important? So, when we talk about fiber maturity in cotton, what's important there with cotton specifically is that maturity matters because it's the way the fiber structure develops at maturity. So if you have an immature kind of cotton fiber, it's almost flat, right? It's flat sided, like kind of like a tapeworm, right? But as it matures, it actually rounds out, right? And so you have something that looks closer to like an oval or a circle, and that's really important when it comes to spinning, right? Because when you have these flat fibers going through these spinners at high speed, you know, if it if if the twists are happening around these flat sides, that's not a whole lot of surface area, right? But if you have obviously oval round fibers all going through, that keeps the process efficient, that keeps um, the yarn tight and held together, right? When I talk about maturity with hemp fiber, what I'm saying is that I'm sure you've seen it too. you know, there's some literature out there that says, well, you can harvest early, right? You can harvest early. You got immature hemp plants you can harvest early, and this makes really good fiber quality, right? You see some that say, harvest your crop 5 weeks after flowering or seeding, and that has really good hemp fiber quality, right? Um, so when I talk about maturity, what I'm saying is that it's the concept of, does the property of the hemp fiber really change from uh the emergence, to senescence, right? Um and so that's something that we like to explore, because when it comes down to it, it's is there an optimal time to harvest? I mean, just be thinking off the top of my head. Is there an optimal time to harvest hemp fiber crops for a specific end use? So if we got immature plants and we're harvesting them earlier, and they produce really good fiber that could be good for apparel, just throwing it out there, right? Compared to something that actually reaches its life cycle, and could be used for baskets or whatever, right? Sacks. That's the kind of maturity that we're looking at. And I hope that answers your question, because I kind of rambled there. And then to Matthew, do we accept samples for testing? We accept samples for testing. Bring them. We are not turning down samples. So we've kind of become the hub, especially in ARS, of sample collection, and again, the idea is that once we start getting these instruments and technologies and these methods online, it would be nice to have different sample types and different materials already on hand to run these things through. So, oh look, so Mr. McLaughlin, I guess he had the same question. Do you think that the harvest time in terms of optimal fiber properties, what do you think of it? And so I don't know if you heard my rant, but that's what I think. I don't know. I don't know yet. I hear a lot of things. I've read a lot of things. But you're probably just like me. You got to see it to believe it. But it's something, I really think it's something worth exploring. Because again, if that matters, right? If at a certain stage fiber quality is really good and it could be used for high-end products, that's tremendous value there. And so from Joan from IND Hemp, she wrote, what are your current customers telling you that is most important parameter for now? Well, thanks for the question, Joan. I personally don't have any, I guess, or clients or customers. I've had a couple interactions with Bast Fiber Tech. I think the one thing that they brought up is an issue. Well, I wouldn't say an issue, but the one thing they mentioned that is that 90% of the raw hemp that they're getting is unretted. And so it sounds like you know, they're having to do some things to kind of, further condition their fiber. But that seems to be, something they're, I guess it's something they mentioned. Um, but Joan, I don't know, again, I really think, I mean, historically, right? If you really look at what we've ever used hemp for, it's not because it feels good, right? But when you need a strong material, hemp was always there, and that's why I kind of think, that's gonna be a huge parameter. And again, if we're exploring new applications, I worked with in my military time, I worked with a lot of composites, and I can see the value of using hemp as like reinforcement panels and things like that. Um, and so and of course it is a small hurdle because the kind of plastics um, are hydrophobic and hemp is hydrophilic, and there's something in between that we have to figure out to kind of make that um, composite material bind and get together. Um, but yeah, nobody's telling me much about what's important, what they're looking for specifically. But I will tell you, I think strength is going to matter. So, oh, for primary processing materials, I mean. So Laura Sullivan, she wrote our hemp fibers aggregates. Is there a moment you can get to a single fiber? Laura, yes, you can. You can get to a single fiber. And again, it's one of those ideas that is there a genotype that can actually is there a genotype out there that can actually break up, that doesn't bundle as much, right? We haven't found it just yet, but there could be one, right? And if we could get, Laura, if we could get to a single fiber, and or close to it, right, and have you know hemp kind of be somewhat individualized, I mean, the application for that would be amazing, right? Now, if you saw on that slide from Texas Tech, you can condition hemp fiber to the point where it's really cottonized. It's looks the same consistency. It looks just like cotton after bleaching and everything, but you can, if you get to that point, you can probably pull out a few single fibers out of that. And then Laura, yes, I will take your samples. Oh, thank you for the thesis, by the way. I think that's pronounced Andrea. There's two N's in there. That's got to be Andrea, right? Thank you for the thesis. I need the info, right? I need the literature so I can review a lot of things, because there's a lot of stuff out there, and so I really appreciate that.
So it looks like we got to the end of the questions. Thank you so much, Wayne, for your presentation today. That was awesome. It's great to hear about the work that the USDA is doing. As a reminder for everyone, we're going to meet again in 2 weeks, where Lynn Sosnowski from Cornell is going to talk about weed management in cultivation. So I'll see everyone in 2 weeks. Thank you again, Wayne.
Thank you. Thanks, Bahia. Thanks, everybody.
This has been a production of Cornell University, on the web at cornell.edu.